Okay, one other concept for series that generalizes what you've seen for series of real numbers in calculus, but in an arbitrary normed space, we say a series, summation as n goes from 1 to infinity, of x of n, converges absolutely if the series of norms converges. Summation as n goes from 1 to infinity of norm of x of n converges. And of course, this convergence takes place in the real numbers, the one-dimensional norm space where the norm is the absolute value. Notice that this is a series of non-negative real numbers. To say that that converges is the same as saying that the upper bound of the partial sums is finite, and we just say that the sum of the non-negative terms, x of n, is less than infinity. Now, in the real numbers, you saw that every absolutely convergent series converges. This turns out to be another one of those properties that rests upon completeness of the real numbers, the least upper bound property. In general, this turns out to be a very useful test for completeness of a normed space X. Our first theorem, something you might not have seen in this generality before, is that our normed space X is complete if and only if every absolutely convergent series converges. So the result from calculus just says that the real numbers are complete. Before we get into the proof of this, let's talk about it a little bit, maybe make sure we understand what's at stake here. We're in an arbitrary normed space X, so we have the concept of sequences and series, absolute convergence, etc. And we're saying that X is a Banach space if and only if every series for which the sum of the norms converges in the real line converges itself in the normed space X. I'm going to start the proof. As usual, let's start it here, with an if and only if proof. It turns out that one of the two directions is much easier than the other. So we start with the forward direction. So we assume X is complete. And we have to prove that every absolutely convergent series converges. So I take an absolutely convergent series, so let summation n goes from 1 to infinity x of n be absolutely convergent. I have to show that it converges.